Grand existence. Grand existence. Almost forgot to do a sound check. I'm gonna just turn me all the way up, and if that hurts your ears, turn me down on your end, because I'd rather be too loud than too quiet, you know? Alright, thank you for joining me here. Grand existence, welcome back to the Pharmacopoeia, JDP. And I'm gonna jump right back in where I left off here on page 47. I'm gonna try to zoom in so you can see a little bit about what's going on. Maybe you want to read along with me. I don't know. I am honored to have you here. And let me just send one text. I am in love with you. I had to send a text to my lady. Alright. Absolutely. Alright, sorry for the delay, folks. Got a text her. Just love my life. Alright, so if the volume is too loud for you, turn your volume down. It's better for me to be loud than for me to be quiet. So, I left off right here on this word thought. This is the highest form of musicality in the sphere of thought. Now I continue forward with Einstein's autobiographical notes. Einstein, the Philosopher-Scientist. If you missed the first two parts, go listen. I know you've been waiting, so here I go. Literally not waiting anymore. My own interest in those years was less concerned with the detailed consequences of Planck's results, however important these might be. My major question was, what general conclusions can be drawn from the radiation formula concerning the structure of radiation, and even more generally concerning the electromagnetic foundation of physics? Before I take this up, I must briefly mention a number of investigations which relate to the Brownian motion and related objects (parentheses, fluctuation phenomena, end parentheses), and which in essence rest upon classical molecular mechanics. Not acquainted with the earlier investigations of Boltzmann and Gibbs, which had appeared earlier and actually exhausted the subject, I developed the statistical mechanics and the molecular kinetic theory of thermodynamics, which was based on the former. My major aim in this was to find facts which would guarantee as much as possible the existence of atoms of definite finite size. Einstein, I do laugh at you for that as a student of the atom. Well, we know now. We just know too much now, so I must laugh a little bit, but not really, because anyways, this is not about me. Sorry. In the midst of this, I discovered that, according to atomistic theory, there would have to be a movement of suspended microscopic particles open to observation, without knowing that observations concerning the Brownian motion were already long familiar. The simplest derivation rested upon the following consideration. If the molecular kinetic theory is essentially correct, a suspension of visible particles must possess the same kind of osmotic pressure, fulfilling the laws of gases as a solution of molecules. This osmotic pressure depends upon the actual magnitude of the molecules, i.e., upon the number of molecules in a gram equivalent. If the density of the suspension is inhomogeneous, the osmotic pressure is inhomogeneous too, and gives rise to a compensating diffusion, which can be calculated from the well-known mobility of the particles. Sorry, I'm just going to make sure that I need to do a sound check. Let me get a sound check real quick. Because if y'all can't hear me, I think I can hear me. It looks like I have sound. I am live. What's going on over here? Yep. Yeah, we're live. Sorry for the little detour. Back to the Brownian motion. By comparing, this diffusion can, on the other hand, also be considered as the result of the random displacement, unknown in magnitude originally, of the suspended particles due to the thermal agitation. By comparing the amounts obtained for the diffusion current from both types of reasoning, one reaches quantitatively the statistical law for those displacements, i.e. the law of the Brownian motion. The agreement of these considerations with experience, together with Planck's determination of the true molecular size from the law of radiation for high temperatures, convinced the skeptics, who were quite numerous at the time, Ostwald, Mach, of the reality of atoms. The antipathy of these scholars towards atomic theory can indubitably be traced back to their positivistic philosophical attitude. This is an interesting example of the fact that even scholars of the audacious spirit and fine instinct can be obstructed in the interpretation of facts by philosophical prejudices. The prejudice, which has by no means died out in the meantime, consists in the faith that facts by themselves can and should yield scientific knowledge without free conceptual construction. Such a misconception is possible only because one does not easily become aware of the free choice of such concepts, which through verification and long usage appear to be immediately connected with the empirical material. That's a name for a band, right? Empirical material. The success of the theory of the Brownian motion showed again conclusively that the classical mechanics always offered trustworthy results whenever it was applied to motions in which the higher time derivatives of velocity are negligibly small. Upon this recognition, a relatively direct method can be based which permits us to learn something concerning the constitution of the radiation from Planck's formula. One may conclude, in fact, that in a space filled with radiation, a freely moving, quasi-monochromatically reflecting mirror vertically to its plane would have to go through a kind of Brownian movement. The average kinetic energy of which equals 1/2 R divided by N times T, where R equals the constant of the gas equation for a 1 gram molecule, N equals the number of molecules per mole, and T equals the absolute temperature. Shout out chemists, we're all familiar. If radiation were not subject to local fluctuations, the mirror would gradually come to rest because, due to its motion, it reflects more radiation on its front than on its reverse side. Look, y'all, I'm not going to pretend to understand all this, but some things I have a glimmer of understanding, and other things I'm like, these dudes are schizo. What the F are they talking about? But just hearing the words, going through the knowledge, allowing it to permeate the consciousness, I think will do something. So that's part of my motivation in reading this, but oh, shit. That's okay. We don't need to do that. Got an error on my computer, but we should be Gucci, so we're going to keep going. Always with the errors. No more errors. Lord, lead us not into error nor confusion, but lead us into truth and understanding. However, the mirror must experience certain random fluctuations of the pressure exerted upon it due to the fact that the wave packets constituting the radiation interfere with one another. These can be computed from Maxwell's theory. This calculation then shows that these pressure variations, especially in the case of small radiation densities, are by no means sufficient to impart to the mirror the average kinetic energy, 1/2 R divided by N times T. In order to get this result, one has to assume rather that there exists a second type of pressure variations, which cannot be derived from Maxwell's theory, which corresponds to the assumption that radiation energy consists of indivisible, point-like, localized quanta of the energy hv and the momentum hv divided by c, where c equals the velocity of light, which are reflected undivided. This way of looking at the problem showed in a drastic and direct way that a type of immediate reality has to be ascribed to Planck's quanta, that radiation must, therefore, possess a kind of molecular structure in energy, which of course contradicts Maxwell's theory. Considerations concerning radiation, which are based directly on Boltzmann's entropy probability relation, probability taken equal to statistic temporal frequency, also lead to the same result. What the fuck are these guys talking about? I'm sorry. This double nature of radiation and of material corpuscles is a major property of reality, which has been interpreted by quantum mechanics as an ingenious and amazingly successful fashion. This interpretation, which is looked upon as essentially final by almost all contemporary physicists, appears to me as only a temporary way out. A few remarks to this point, no pun intended, will follow later. Reflections of this type made it clear to me as long ago as shortly after 1900, i.e. shortly after Planck's trailblazing work, that neither mechanics nor electrodynamics could, except in limiting cases, claim exact validity. By and by, I despaired of the possibility of discovering the true laws by means of constructive efforts based on known facts. The longer and the more despairingly I tried, the more I came to the conviction that the only discovery of a universal formal principle could lead us to assured results. The example I saw before me was thermodynamics. The general principle that was there given in the theorem: the laws of nature are such that it is impossible to construct a perpetuum mobile of the first and second kind. How then, what? I'm going to look this up, y'all, for us. Perpetuum mobile. In music, moto perpetuo, movement perpetuel, is a term used to describe a rapidly executing and persistently maintained figuration, usually of notes of equal length. Okay, that didn't help me. How then could such a universal principle be found? After 10 years of reflection, such a principle resulted from a paradox upon which I had already hit at the age of 16. If I pursue a beam of light with the velocity c, velocity of light in a vacuum, I should observe such a beam of light as a spatially oscillatory electromagnetic field at rest. I can see that in my brain. However, there seems to be no such thing, whether on the basis of experience or according to Maxwell's equations. Am I too close to my microphone? From the very beginning, it appeared to me intuitively clear that, judged from the standpoint of such an observer, everything would have to happen according to the same laws as for an observer who, relative to the earth, was at rest. For how, otherwise, should the first observer know, i.e., be able to determine that he is in a state of fast, uniform motion? One sees that in this paradox the germ of the special relativity theory is already contained. Today, everyone knows, of course, that all attempts to clarify this paradox satisfactorily were condemned to failure as long as the axiom of the absolute character of time, viz. What does viz mean? I see that visually. Viz. The abbreviation viz is short for the Latin videlicet, which itself is a contraction of the Latin phrase videre licet, meaning it is permitted to see. Okay, great. Starting that sentence over. Today, everyone knows, of course, that all attempts to clarify this paradox satisfactorily were condemned to failure as long as the axiom of the absolute character of time, wait, what does it mean? You know what it means. No, I don't. Sorry, we're looking at it again. I read too much of this sentence, and that is to say, that it is permitted to say, that is to say of simultaneity, unrecognizably was anchored in the unconscious. Like, these dudes are living up in their consciousness. Clearly, to recognize this axiom and its arbitrary character really implies already the solution of the problem. The type of critical reasoning which was required for the discovery of this central point was decisively furthered, in my case, especially by the reading of David Hume's and Ernst Mach's philosophical writings. It's fantastic. One had to understand clearly that the spatial coordinates and the temporal duration of events meant in physics. I think I said that instead of what. One had to understand clearly what the spatial coordinates and the temporal duration of events meant in quantum physics. The physical interpretation of the spatial coordinates presupposed a fixed body of reference, which, moreover, had to be in a more or less definite state of motion, inertial system. In a given inertial system, the coordinates meant the results of certain measurements with rigid, stationary rods. One should always be conscious of the fact that the presupposition of the existence in principle of rigid rods is a presupposition suggested by approximate experience, but which is in principle arbitrary. With such an interpretation of the spatial coordinates, the question of the validity of Euclidean geometry becomes a problem of physics. If, then, one tries to interpret the time of an event analogously, analogously, don't say it like that. One needs a means for the measurement of the difference in time in itself determined periodic process, realized by a system of sufficiently small spatial extension. A clock at rest relative to the system of inertia defines a local time. The local times of all space points taken together are the, quote, time which belongs to the selected system of inertia. If a means is given to set these clocks relative to each other, one sees that a priori is not at all necessary that the times thus defined in different inertial systems agree with one another. One would have noticed this long ago if, for the practical experience of everyday life, light did not appear as the means for the statement of absolute simultaneity because of the high value of C. The presupposition of the existence in principle of ideal or perfect measuring rods and clocks is not independent of each other. Let me read that again. The presupposition of the existence of measuring rods and clocks is not independent of each other. Since a light signal which is reflected back and forth between the ends of a rigid rod constitutes an ideal clock, provided that the postulate of the constancy of the light velocity in vacuum does not lead to contradictions. The above paradox may then be formulated as follows. According to the rules of connection, used in classical physics of the spatial coordinates of the time of events in the transition from one inertial system to another, the two assumptions of one, the constancy of the light velocity, and two, the independence of the laws, thus especially also of the law of the constancy of the light velocity, of the choice of the inertial system. Let me read that second one again, without the parentheses. The independence of the laws of the choice of the inertial system are mutually incompatible. The insight which is fundamental for the special theory of relativity is this. The assumptions 1 and 2 are compatible if relations of a new type, the Lorentz transformation, are postulated for the conversion of coordinates in the times of events with the given physical interpretation of coordinates in time. This is by no means merely a conventional step, but implies certain hypotheses concerning the actual behavior of moving measuring rods and clocks, which can be experimentally validated or disproved. I don't know about y'all, but maybe I missed something on 10 pages ago, because what the fuck are these rods and clocks all about? Maybe some plant medicine will help me understand. It's officially turning into a plant medicine and chill audiobook session. Thank you, God. That's it. That's all she wrote. Just to expand the mind a little bit. With the given physical with the given physical interpretation of coordinates and time, this is by no means merely a conventional step, but implies certain hypotheses concerning the actual behavior of moving measuring rods and clocks, which can be experimentally validated or disproved. The universal principle of special theory of relativity is contained in the postulate the laws of physics are invariant with respect to the Lorentz transformations for the transition from one inertial system to any other arbitrarily chosen system of inertia. This is a restricting principle for natural laws, comparable to the restricting principle of the non-existence of the perpetuum mobile, which underlies thermodynamics. First, a remark concerning the relation of the theory to the four-dimensional space. Quote, four-dimensional space. Said as if it's not real. It is a widespread error that the special theory of relativity is supposed to have, to a certain extent, first discovered, or at any rate newly discovered, the four-dimensionality of the physical continuum. This, of course, is not the case. Of course it's not the case, man. Of course, there's at least 12. Haven't you read anything from Einstein? All right. This, of course, is not the case. Classical mechanics, too, is based on the four-dimensional continuum of space and time. But in the four-dimensional continuum of classical physics, the subspaces with constant time value have an absolute reality, independent of the choice of the reference system. Oh, my leg's falling asleep. Bloody hell. Because of this fact, the four-dimensional continuum falls naturally into a three-dimensional and a one-dimensional time, so that the four-dimensional point of view does not force itself upon one as necessary. The special theory of relativity, on the other hand, creates a formal dependence between the way in which the spatial coordinates on the one hand and the temporal coordinates on the other have to enter into the natural laws. Minkowski's important contribution to the theory lies in the following. Before Minkowski's investigation, it was necessary to carry out the Lorentz transformation on a law in order to test its invariance under such transformations. He, on the other hand, succeeded in introducing a formalism that the mathematical form of the law itself guarantees its invariance under Lorentz transformations. By creating a four-dimensional tensor calculus, he achieved the same thing for the four-dimensional space which the ordinary vector calculus achieves for the three spatial dimensions. He also showed that the Lorentz transformation, apart from a different algebraic sign due to the special character of time, is nothing but a rotation of the coordinate system in the four-dimensional space. Typical. First, a remark concerning the theory as it is characterized above. One is struck by the fact that the theory, except for the four-dimensional space, introduces two kinds of physical things, i.e. 1, measuring rods and clocks. Here we go again with the rods and the clocks. 2, all other things, e.g. the electromagnetic field, the material point, etc. We love the material point at JDP. This, in a certain sense, is inconsistent. Strictly speaking, measuring rods and clocks would have to be represented as solutions of the basic equations, objects consisting of moving atomic configurations, not, as it were, as theoretically self-sufficient entities. However, the procedure justifies itself because it was clear from the very beginning that the postulates of the theory are not strong enough to deduce them from sufficiently complete equations for physical events sufficiently free from arbitrariness in order to base upon such a foundation a theory of measuring rods and clocks. If anybody understands what we're reading, let me know. I would like to talk to you. Isn't there something about like a theory is not truly like good if it's not simple and elegant and like that you can explain it to a kid in 5th grade? Like, what's these guys talking about? If one did not wish to forgo a physical interpretation of the coordinates in general, something which in itself would be possible, it was better to permit such inconsistency with the obligation, however, of eliminating it at a later stage of the theory. I think I read the cadence on that sentence was fucked up, but I don't know. We're going to just keep marching. But one must not legalize the mentioned sin so far as to imagine that intervals are physical entities of a special type, intrinsically different from other physical variables, reducing physics to geometry, etc. We now shall inquire into the insights of definite nature which physics owes to the special theory of relativity. We now shall inquire into the insights of definite nature which physics owes to the special theory of relativity. There is no such thing as simultaneity of distant events. So what does that really? When was this written? Can we know? Einstein Autobiography. What are we calling it? The published date. 1949. He was still alive. Le Prix Nobel. Okay, so that's just context. I knew that, but I forgot it, so I guess I didn't know it. I just had heard that before. So let's read that again. And if you know, I understand about 1% of this book, and it's right here. It's like 0.1 of that 1% is right here. There is no such thing as simultaneity of distant events. Get ready to be humbled, Einstein. Consequently, there is also no such thing as immediate action at a distance in the sense of Newtonian mechanics. Although the introduction of actions at a distance which propagate with the speed of light remains thinkable. According to this theory, it appears unnatural, for in such a theory there could be no such thing as a reasonable statement of the principle of conservation of energy. It therefore appears unavoidable that physical reality must be described in terms of continuous functions in space. The material point, therefore, can hardly be conceived anymore as the basic concept of the theory. You know, if you've read the Tom Campbell's big theory of everything, you realize, well, you can kind of you can see things when they boil it all up into these maxims and these axioms and they boil it all down. You know, I don't understand it all, but some of it I do understand. And let me tell you right now, reality is not a continuous, physical reality is not a continuous function in space. There are discrete packets of information inside of light particles and photons which contain consciousness information. They're discrete packets. You can't go, it's the age-old axiom, you can't go halfway to something. It's like me here, wall there. I'm going to go halfway, and then halfway, and then halfway again, and halfway. And can you just go halfway into infinity and never reach the wall? No, you can't. The new science, Einstein would say yes. It appears to me Einstein would say yes. He said you can keep going infinitely because there's a continuous function in space. But Tom Campbell would say no. You can't. Eventually, you reach a point where you can't move half the space. You have to move the whole space. And he basically calls that space the Planck space, the Planck distance. And it is, in essence, a pixel. We live in a pixelated reality, but there's like layers of pixels on top of layers of pixels. There's screens on top of screens, sheets on top of sheets. The reality is covered in sheets, and there's so anyways, that's another book. We'll read that one later. The material point, therefore, can hardly be conceived anymore as the basic concept of the theory. The principles of the conservation of momentum and of the conservation of energy are fused into one single principle. I like that. The inert mass of a closed system is identical with its energy, thus eliminating mass as an independent concept. Remark. Do you have to say remark, Einstein, or can you just say it? The speed of light, c, is one of the quantities which occurs as a universal constant in physical equations. It's not. If, however, one introduces as unit of time instead of the second the time in which the light travels 1 centimeter, c no longer occurs in the equations. In this sense, one could say that the constant c is only an apparently universal constant. There we go. We wrapped it up. I agree, but I don't understand shit, but I agree. It is obvious and generally accepted that one could eliminate 2 more universal constants from physics by introducing, instead of the gram and the centimeter, properly chosen natural units. For example, mass and radius of the electron. Ooh, now we're talking, Einstein. I like where this is headed. He's certainly taking me on a roller coaster. If one considers this, considers what? Considers this, then only, quote, dimensionless constants could occur in the basic equations of physics. Concerning such, I would like to state a theorem which at present cannot be based upon anything more than upon a faith in the simplicity, i.e., intelligibility of nature. There are no arbitrary constants of this kind. That is to say, nature is so constituted that it is possible logically to lay down such strongly determined laws that within these laws only rationally, completely determined constants occur, not constants, therefore, whose numerical value could be changed without destroying the theory. The special theory of relativity owes its origin to Maxwell's equations of the electromagnetic field. Inversely, the latter can be grasped formally in satisfactory fashion only by way of the special theory of relativity. Maxwell's equations are the simplest Lorentz invariant field equations which can be postulated for an antisymmetric tensor derived from a vector field. This in itself would be satisfactory if we did not know from quantum phenomena that Maxwell's theory does not do justice to the energetic properties of radiation. But how Maxwell's theory would have to be modified in a natural fashion, for this, even the special theory of relativity offers no adequate foothold. Also, to Mach's question, how does it come about that inertial systems are physically distinguished above all other coordinate systems? Good question. This theory offers no answer. That the special theory of relativity is only the first step of a necessary development became completely clear to me only in my efforts to represent gravitation in the framework of this theory. In classical mechanics, interpreted in terms of the field, the potential of gravitation appears as a scalar field, the simplest theoretical possibility of a field with a single component. Such a scalar theory of the gravitational field can easily be made invariant under the group of Lorentz transformations. Does anybody know what a Lorentz transformation is? I have to look it up. I'm going to look up that and Brownian motion later. I'm going to look up Lorentz transformations right now. I can give you the AI. There is no AI. In physics, Lorentz transformations are a 6-parameter family of linear functions from a coordinate frame in space-time to another frame that moves at a constant velocity relative to the former. The respective inverse transformation is then, 5. The Lorentz transformation, imagine you have a friend on a fast train and you're standing still. The Lorentz transformation is how you figure out what your friend is seeing and how they see what you're seeing. It shows that the faster you go, the slower time goes for you, and things in your direction of travel get shorter. Okay, so we're going to meditate on that in the background and keep moving forward. Where did we leave off? Natural fashion, foothold, inertial systems, distinguish, relatively only the first step is necessary. Okay, the following program appears natural, therefore, the total physical field consists of a scalar field, gravitation, and a vector field, electromagnetic field. Later insights may eventually make necessary the introduction of still more complicated types of fields. For sure. What about the consciousness field, brah? But to begin with, one did not need to bother about this. The possibility of the realization of this program was, however, dubious from the very first, because the theory had to combine the following things. 1, from the general considerations of special relativity theory, it was clear that the inert mass of a physical system increases with the total energy. The inert mass of a physical system increases with the total energy, e.g. kinetic energy. Okay, 2, from very accurate experiments, especially from the torsion balance experiments of I don't know how to fuck. Otvos. O with 2 dots above it in both of them. Somebody drop in the comments how to pronounce that. It was empirically known with very high accuracy that the gravitational mass of a body is exactly equal to its inert mass. There's something under my table breaking. If everything falls apart, we're going to have to end the stream, but I'll be back. Just like Jesus. The condition. Sorry, Lord, I didn't mean to take your son's name in vain. Or did I? If the theory did not accomplish this or could not do it naturally, I got to start number 2 basically over. Sorry. So from very accurate experiments, the Autobiographical experiments, it was empirically known with very high accuracy that the gravitational mass of a body is exactly equal to its inert mass. I mean, that checks out to me. That sounds very logical. Your mass is your mass. I am that I am. What would it be? It followed from 1 and 2 that the weight of a system depends in a precisely known manner on its total energy. If the theory did not accomplish this or could not do it naturally, it was to be rejected. The condition is most naturally expressed as follows. The acceleration of a system falling freely in a given gravitational field is independent of the nature of the falling system. The acceleration of a system falling freely in a given gravitational field is independent of the nature of the falling system. That checks out. Especially, therefore, also of its energy content. It then appeared in the framework of the program sketched, this elementary state of affairs could not at all, or at any rate not in any natural fashion, be represented in a satisfactory way. This convinced me that within the frame of the special theory of relativity, there is no room for a satisfactory theory of gravitation. Now it came to me the fact of the equality of inert and heavy mass, i.e., the fact of the independence of the gravitational acceleration of the nature of the falling substance, may be expressed as follows. Bro just used a colon in a sentence and then used another colon before he used a period, so I don't know. I don't know if that's linguistically allowed. It may be expressed as follows. In a gravitational field of small spatial extension, things behave as they do in a space free of gravitation. If one introduces in it, in place of an inertial system, a reference system which is accelerated relative to an inertial system. If then one conceives of the behavior of a body in reference to the latter reference system as caused by a, quote, real, or not merely apparent, gravitational field, it is possible to regard this reference system as an inertial system with as much justification as the original reference system. So if one regards as possible gravity fields of arbitrary extension which are not initially restricted by spatial limitations, the concept of the, quote, inertial system becomes completely empty. The concept, acceleration relative to space, then loses every meaning, and with it the principle of inertia together with the entire paradox of Mach. The fact of the equality of inert and heavy mass thus leads quite naturally to the recognition that the basic demand of the theory of relativity, invariance of the laws under Lorentz transformations, is too narrow, i.e., that an invariance of the laws must be postulated also relative to nonlinear transformation of the coordinates in the four-dimensional continuum. This happened in 1908, which we really should call 1908 when you think about it. I'm going to carry my microphone like this, yeah. Why were Why were another 7 years required for the construction of the general theory of relativity? Einstein asks. The main reason lies in the fact that it is not so easy to free oneself from the idea that coordinates must have an immediate metrical meaning. The transformation took place in approximately the following fashion. We start with an empty field free space, as it occurs, related to an inertial system. In the sense of the special theory of relativity, as the simplest of all imaginable physical situations. If we now think of a non-inertial system introduced by assuming that the new system is uniformly accelerated against the inertial system in a three-dimensional description in one direction, conveniently defined, then there exists with reference to this system a static parallel gravitational field. The reference system may thereby be chosen as rigid, of Euclidean type in three-dimensional metric relations. By the time in which the field appears as static is not measured by equally constituted stationary clocks. From this special example, one can already recognize that the immediate metric significance of the coordinates is lost if one admits nonlinear transformations of coordinates at all. To do the latter is, however, obligatory if one wants to do justice to the equality of gravitational and inert mass by means of the basis of the theory, and if one wants to overcome Mach's paradox as concerns the inertial systems. If, then, one must give up the attempt to give the coordinates an immediate metric meaning, parentheses, differences of coordinates equals measurable lengths or times. One will not be able to avoid treating as equivalent all coordinate systems which can be treated by the continuous transformations of the coordinates. The general theory of relativity accordingly proceeds from the following principle. Natural laws are to be expressed by equations which are covariant under the group of continuous coordinate transformations. This group replaces the group of the Lorentz transformations of the special theory of relativity, which forms a subgroup of the former. Rip Lorentz. This demand by itself is of course not sufficient to serve as the point of departure for the derivation of the basic concepts of physics. In the first instance, one may even contest the idea that the demand by itself contains a real restriction for the physical laws, for it will always be possible thus to reformulate a law postulated at first only for certain coordinate systems such that the new formulation becomes formally universally covariant. By this, it is clear from beginning that in an infinitely large number of field laws can be formulated which have this property of covariance. The eminent heuristic significance of the general principles of relativity lies in the fact that it leads us to the search for those systems of equations which are in their general covariant formulation the simplest ones possible. Among these, we shall have to look for the field of equations of physical space, fields which can be transformed into each other by such transformations describe the same real situation. All right, and with that, y'all, I think I'm going to stop it on page 69, rightfully so, and continue this in part 4. Thank you for joining me. Have a grand existence.